In the transportation field, more and more businesses are realizing the benefits of using natural gas as an abundant, safe, and clean-burning alternative to gasoline and diesel fuel. And one of the companies leading the way in alternative fuel storage and delivery is Agility Fuel Systems. Hello, I'm Tony Noakes. At Agility, our goal is to provide timely, world-class engineering, installation, support, advice, and aftermarket service that makes it easy for our customers to modernize their fleets of heavy-duty trucks, buses, and specialty vehicles. In business since 1996, Agility Fuel Systems has deployed over 20,000 systems in fleets across North America and around the world. Agility manufactures and installs natural gas fuel systems at our facilities in California, Alabama, and British Columbia, while service is available through our network of factory-certified dealers or right at your site, ensuring the highest level of customer satisfaction. In this video, we're going to take a closer look at compressed natural gas, CNG, and how it's used to safely power vehicles. And we'll show you how to work with an Agility CNG system and how to perform basic maintenance and troubleshooting. Our objective is to raise your awareness and knowledge of these systems to ensure their safe and efficient operation. This program is divided into 12 segments, starting with this introduction. Then we go into a system overview, system components, fueling and defueling, the daily system inspection, pressure relief devices, depressurizing the system, how to service the high pressure filter, leak detection and repair, hot work, troubleshooting, and last, how to contact Agility Fuel Systems for product support. Helping me today will be Chris Chokas. Hey Chris, welcome. He's an Agility Service Advisor, and he'll be demonstrating the proper procedures as well as showing you some of the features and functions throughout this presentation. Good to go? Let's get started. In this segment, we're going to review what makes CNG unique, and then we'll take a look at a typical Agility CNG system. As you know, natural gas is flammable. However, it only burns within a narrow range when mixed with air in a ratio of between 5 and 15%. CNG will not burn in the highly concentrated form found inside cylinders. Also, natural gas is odorless, tasteless, and non-toxic. That is why mercaptan is injected into the gas to give it that rotten egg odor, which allows for easier leak detection. Another fact, natural gas is lighter than air and rises quickly and diffuses into the atmosphere when released. Plus, if you've ever wondered, natural gas has an octane rating of 130. And all CNG vehicles must display this blue diamond symbol. Now, let's take a look at a typical CNG system. It consists of the CNG cylinder, and on most heavy vehicles there will be multiple cylinders. Gas is stored in these cylinders at a nominal pressure of 3,600 pounds per square inch. Each cylinder has one or more pressure relief devices, or PRDs. From the cylinder, gas flows to the Fuel Management Module, FMM for short, where it's filtered and regulated down to a nominal pressure of 125 psi. From there, the gas goes through a low-pressure filter to the engine. As we go along, we'll describe each of these components in more detail. By the way, just to be clear, storage vessels for CNG are called cylinders, while liquid natural gas storage vessels are called tanks. Every vehicle also has protective shielding. Typically, it can be found on the roof, at the sides, or in back of the cab. And the cylinders are located inside the protective shielding, which has been removed here for clear visibility. This is a side rail mounted system showing a CNG cylinder with its manual shutoff valve. This cylinder is protected by remote PRDs and feeds a standalone FMM. And this is a different style of side mount system that's referred to as an integrated side mount. It has the FMM built into the CNG system package and has remote PRDs. Here's a look at a back of cab system, which also contains remote PRDs and the FMM. CNG cylinders and cylinder valves must be protected from various factors like road hazards, direct sunlight, exhaust heat, and physical damage. This is accomplished by using the structure of the vehicle or by adding valve protectors or a suitable shield. Agility fuel systems come as a complete package. The fuel lines, cylinders, and all CNG fuel management components are housed in protective shielding. Stainless steel is the preferred material for CNG tubing and fittings, and Agility uses stainless steel whenever possible. Coming up next, system components. Now, let's follow the flow of gas from a cylinder through the components to the engine. From the cylinder through the cylinder shutoff valve, high-pressure gas goes to the FMM. The FMM houses all the Agility CNG control components, such as the regulator, high-pressure filter, and various valves. The high-pressure regulator reduces the gas pressure from 3,600 psi to approximately 125 psi. Gas at 125 psi leaves the regulator and goes to the low-pressure filter, which is not part of the Agility system. A hose goes from the low-pressure filter, routing gas to the engine. At the engine, an internal regulator further reduces the gas pressure. Now, let's take a closer look at the features Agility offers on an FMM in a typical system. The red handle is the quarter-turn shutoff valve. This shuts off the fuel from the FMM to the engine. You would close this valve when you want to work in the engine compartment, like when removing the cylinder heads, changing spark plugs, or anything along those lines. You don't want to have any gas in the engine bay for that kind of work. Remember, never adjust, remove, or tighten a fitting or connector on a fuel system that is under pressure. Be sure to review Segment 7, Depressurizing the System, for more information. Next is the fast high-volume fill receptacle. You can use this receptacle to fill your vehicle with a high-volume nozzle. This is the NGV1 fuel receptacle, which is a standard fueling receptacle found across the U.S. This is the defueling receptacle. It permits the fuel in the cylinders to be removed when necessary. Here is the high-pressure gauge. When all of the valves are in the open position, this gauge tells you the pressure in the cylinders. And this is the low pressure gauge, which tells you what the gas pressure is coming out of the regulator and going to the engine. Nominal pressure here is 125 psi. Now we're going to take you inside the fuel management module. As you can see, we've moved off the vehicle to a bench top for a better view inside. Here are the regulator coolant port in and the coolant port out. These ports bring hot coolant from the engine to the regulator bowl and then back to the engine. The coolant cycles inside the bowl, keeping the regulator warm. Without the warm coolant, the regulator could freeze up as the gas expands, passing through the regulator. These are the pressure regulator and the pressure relief valve. The pressure regulator has its own pressure relief valve. This is the only pressure relief valve in the system that is actually activated by pressure. If there is too much gas pressure exiting the regulator, over 200 psi, this valve will relieve that pressure, then automatically reset. Next is the wiring harness, and all wires are identified as to their function. Here we see the manifold bleed valve and manifold. The manifold is a hub where the gas is distributed to various places in the system. The quarter-turn manual shutoff valve is the red-handled one we showed earlier on the front panel. This is the defuel valve. Here is the check valve to prevent backflow. And these are the high-pressure filter housing, bowl, and drain plug. We will discuss how to service this filter in Segment 8 of this presentation. This is the solenoid valve. Safety codes require a solenoid gas shutoff valve that is activated by the vehicle ignition key. Finally, this is the high pressure fuel line coming in from the cylinders. Okay, now we're going to take a closer look at a different type of FMM called an integrated unit that we introduced you to earlier in this presentation. This design is used for some side rail mounted systems. Notice that the tubing and routing are a little different, but it uses the same components as before, just in different locations. It includes the red-handled quarter-turn shutoff valve and the high-volume fill receptacle, just as on the previous FMM. Here is the NGV1 fuel receptacle and the high-pressure gauge that shows the pressure in the cylinders. And in here is the low-pressure gauge. This gauge shows the gas pressure leaving the regulator and flowing toward the engine, and the defueling receptacle. Notice that with this style, the low pressure gauge and defueling receptacle are inside the FMM. If you ever see anything about a CNG system that looks questionable, or you are in any doubt, contact your local Agility service provider or Agility before you proceed any further. You'll find Agility's contact information in segment 12. Now that you have a feel for the overall system and system components, let's take a closer look at the various procedures you may perform when working with a CNG system. Fueling vehicles with CNG is a relatively simple procedure when you follow the recommended guidelines that ensure a safe process. Follow along as we show you. To fuel your CNG vehicle, open the FMM door if applicable and remove the dust cap from the fueling receptacle. Wipe down the receptacle and nozzle. Check the O-ring. Then connect the nozzle from the fueling station to the fuel panel receptacle. Next, turn the valve to the fill position and fuel will start to flow. Continue to fuel until the fuel station pump automatically shuts off. Remove the fueling nozzle by turning the valve to the vent position and release it from the receptacle. The receptacles are designed so that the nozzle will not come off if it is still under pressure. Once fueling is complete, replace the cap and close the FMM door. When Agility fuel systems are equipped with optional safety interlocks, the FMM doors or the receptacle caps must be in place in order for the engine to start. Fill receptacles include a check valve to prevent fuel backflow. A second check valve in the fill line adds another layer of safety in case the fill receptacle fails in the open position or is broken off in an accident. If you smell gas while fueling, the fill receptacle may be leaking, so go to the pump and stop fueling. Check the O-ring on the receptacle and replace it if it is worn or damaged. If the O-ring is okay, contact your station provider. Typically, stations fill to a service pressure of 3,600 psi. During fast filling, gas heats up as it compresses in the cylinders, which is normal. So you may end up with 3,600 psi at an elevated temperature, say 120 degrees Fahrenheit or 50 degrees Celsius in the cylinders. Over time, as the gas cools, the ambient temperature, which could be 70 degrees Fahrenheit, 20 degrees Celsius, the pressure in the cylinders decreases. So instead of having a complete fill of 3,600 psi at 70 degrees, you might have only 3,000 psi. Fueling stations can partially compensate for the added heat during fast filling, resulting in a more complete fill, but generally cannot achieve more than 70 or 80% full. Slow filling, on the other hand, results in 100% full because the gas is able to cool during the fill. Some maintenance procedures require removing all the gas from the cylinders, so to do that, follow these steps. The three-way defueling valve inside the FMM is operated manually. There are three positions: defuel, off, and vent. The valve remains off during normal vehicle operation. Before defueling, you should plan for the vehicle being out of service, as it cannot be driven and must be towed. To perform the defueling function, first open the cylinder manual shutoff valve and quarter-turn shutoff valve. Then turn the black handle on the defueling valve to the vent position. Run a properly sized, electrically conductive defuel hose assembly from a defueling post and attach the other end to the defueling port. slowly turn the black handle from vent to defuel. The post will safely vent the gas to the atmosphere. When finished defueling, vent off the system by slowly moving the black handle back to the vent position. Turn the defueling valve to the off position. Finally, you can disconnect the nozzle and the quick connect coupler and replace the cap. That completes fueling and defueling, and we're now ready to cover the daily inspection process. Before operating your vehicle, we recommend that you perform this daily system inspection to ensure it's safe and ready for the road. First, verify that all valves are in the on position. This includes the cylinder manual shutoff valves and the red-handled quarter-turn emergency shutoff valve. Next, make sure the cylinders are filled. Check the high-pressure gauge and refuel if necessary. The engine manufacturer recommends that you drain the low-pressure filter daily before starting the vehicle. Follow the manufacturer's instructions to see if you are getting oil or water in your fuel. Some fueling stations don't filter out oil very well, and this is something that you need to check for. Now, turn the ignition key to the on position and then check the low-pressure gauge, which should show about 125 psi. Note that the dashboard fuel gauge is working. Check the methane detection center for a green light if the vehicle is so equipped. Then, as part of your normal walk-around, check the system for damage, the sound of leaks, frosting, and for the smell of gas. If everything checks out okay, then you're good to go. At Agility Fuel Systems, all of our CNG storage systems meet or exceed NFPA 52, the National Fire Protection Association standard for natural gas vehicles. NFPA 52 requires that each natural gas cylinder have at least one pressure relief device, or PRD, attached to it. The PRD is a one-way valve with a fusible material such as a lead alloy inside. In case of a vehicle fire, when the temperature reaches 219 degrees Fahrenheit, 104 degrees Celsius, the fusible material melts and lets the gas in the cylinder vent safely to the atmosphere. This keeps the cylinder from bursting. PRDs must be in direct communication with the fuel in the cylinder through a non-valved port. You might assume that because they are called pressure relief devices, that pressure causes the release of gas. Actually, it doesn't. These valves are only activated by heat. PRDs are typically found in two locations on each cylinder. One location is at each end if the cylinder has two boss ends. If the cylinder doesn't have bosses on both ends, then it will have remote PRDs attached to it. A live gas line is run from the manual shutoff valve around the back of the cylinder, with PRDs placed in that line at 1/3 and 2/3 of the length of the cylinder. This way, there's always a PRD in proximity to where a flame might occur. A PRD is only good for a single use. A used, leaking, or defective PRD cannot be repaired. It must be replaced. There is no service valve between the PRD and the cylinder. So if you find a leak on a PRD line, or you have a faulty PRD, you must completely defuel the cylinder before repairing the line or replacing the PRD. So those are the important facts about pressure relief devices. Let's move on and review the steps required to depressurize the system. To safely perform various maintenance operations, it is essential that you first depressurize the system. First, isolate the CNG cylinders on the vehicle by turning all cylinder manual shutoff valves clockwise to the off position. Make sure that the red-handled quarter-turn shutoff valve on the FMM is turned to the on position. Start and run the engine until it stalls. This will expend all of the fuel that is in the plumbing lines and manifold. Remove the ignition key. Double check to ensure the vehicle is off and proper vehicle lockout procedures have been followed. Check gauges on the FMM to make sure all pressure has been relieved. Open the FMM box by removing the bolts on the sides and remove the access cover. With a 5/8" box end wrench, open the bleed valve inside the FMM, slowly relieving any remaining pressure. Leave the bleed valve in the open position. The system is now fully depressurized and ready for safe servicing. With the system depressurized, you can safely repair tubing connections or service the high-pressure filter. The high-pressure filter in the CNG system is tasked with removing large amounts of oil contamination from the fuel, which can cause its lifespan to be reduced. Oil carryover at the fueling station isn't always well controlled, so initial change intervals have to be conservatively frequent. That's why we recommend that the high-pressure filter be drained every 1,500 miles or 2,400 kilometers, and the filter element changed every 3,000 miles or 4,800 kilometers. If no oil contamination is found by the third change, you can extend the drain interval to 5,000 miles or 8,000 kilometers and change the element every 10,000 miles or 16,000 kilometers. If at this extended frequency no contamination continues to be found, please contact your local Agility service provider or Agility for recommended service intervals for your vehicle. With the system depressurized, you're ready to drain the high-pressure filter. In this demo, we're using a standalone style FMM, now seen on a benchtop. While the configurations will vary in other styles of FMM, the components are generally the same and the same procedures apply. Start by slowly removing the filter drain plug with an 11/16 wrench. On the vehicle, the FMM is inverted from what you see here. You would now drain the filter until there is no residual liquid left. Inspect the O-ring on the drain plug and replace if necessary. Lube the O-ring and replace the drain plug. Torque to 25 to 30 foot-pounds and mark with torque seal. To replace the filter element, remove the filter bowl from the filter housing using an 1¼ socket wrench. Spin it off and remove the O-ring on the top. Clean the canister inside and out with a clean, dry cloth. Remove the filter element by pulling it off. Be sure to inspect the used filter element for oil pass-through at each filter change. Fueling station compressors with age and lack of proper service can become large oil pumps, causing badly contaminated elements to look like this. Remove the O-ring from the filter element housing. Now remove the old filter element from the housing. Take a new filter element from its packaging and lubricate the O-rings with O-ring specific lube. Be sure this is done, it's very important. Install the new element in the housing and insert the housing into the filter housing port, turning it slightly. With the new O-ring in place, install the bowl and spin it on with your hand. Then tighten to 40 foot-pounds with a torque wrench and mark with torque seal. Close the bleed valve by turning it clockwise with your fingers. Then with your wrench, snug it up about 1/4 turn past finger tight. Now you can repressurize the system by opening the cylinder valves. Checking that the red 1/4 turn shutoff valve is open, and turning the vehicle key to on. This will allow gas pressure to flow throughout the system. Use leak detection solution to check for gas leaks on and around filter housing. That covers servicing the high-pressure filter. Next up, detecting and repairing gas leaks. Detecting and repairing gas leaks is extremely important. You should always follow proper safety and service procedures when working on any CNG system. Failure to do so may result in damage or personal injury. Let's take a few minutes and walk through the key steps in this process. First, and this should be obvious, never use an open flame to search for a gas leak, and do not smoke during any part of this process. Keep all possible ignition sources, such as welding equipment and grinders, away from the system and fueling area. CNG systems should only be serviced in well-ventilated areas. Your shop crew should always be aware of potential hazardous conditions, so inform others in the shop when servicing CNG equipment. And remember, a fitting under pressure should never be tightened, loosened, or checked for tightness, because a fitting that fails under pressure can be extremely dangerous. If you suspect a leak or smell gas, check all of the fittings and connections using certified leak detection equipment. Most leaks will be found at a connection. Start by using a leak detector, a sniffer. Next, use a solution to look for bubbling or foaming at the point of the leak. Always give it at least 10 minutes, since not all leaks will be apparent right away. After a few minutes, even a tiny leak may appear as foam and not bubbles. Examine for frost or ice around tubing or connectors. Frost is an indication of a loose fitting. And finally, check for signs of damage to tubing. Remember, before fixing a leak at a connection, depressurize the system completely as described in segment 7. Tighten a leaking tube fitting by using the proper backup wrench to support the body of the fitting, and then use a second wrench to snug up the tube fitting nut. If a leak cannot be fixed, the component or the tubing must be replaced. When attaching new tubing for the first time, finger tighten the nut and then tighten another half turn with a proper sized wrench. After repressurizing, always retest the repaired parts. By following these important guidelines, you help to ensure your safety and the safety of others. In some cases, the service area where you're working on a CNG system will include hot work, such as welding or grinding. This can create additional safety issues, so be sure to follow these precautions. When welding or grinding more than 6 feet or 2 meters from the CNG system, it is not necessary to defuel the CNG cylinders, but the fuel should be contained in the cylinders by these following steps. Ensure that the vehicle is in a well-ventilated area. Do not park the vehicle in an area where natural gas may accumulate. Fully depressurize the system as described in segment 7. Now, disconnect all electrical plugs at the back of the FMM. However, if you have to perform hot work closer than 6 feet or 2 meters from the CNG cylinders, they must be completely defueled. So see segment 4 for the proper steps to follow. After you have properly defueled the cylinders, all CNG components, including the cylinders and the fuel lines, must be covered with fireproof blankets. A single spark or weld slag could compromise CNG components. If you have any questions on your particular system configuration, please contact your local Agility service provider or Agility product support. Let's face it, sometimes you can encounter a problem that you're not sure about. So here are some basic troubleshooting steps to help you find a resolution. Problem: the engine cranks but won't start. Well, first make sure the red quarter turn shutoff valve and all cylinder valves are open. Then see if the fuel system is providing proper fuel pressure to the engine by checking the high and low pressure gauges at the FMM. Normal ranges are high pressure greater than 500 psi and low pressure 125 plus or minus 10 psi. Note that high pressure less than 500 psi may operate, but the engine is not guaranteed to run at full power. Check the condition of the chassis fuse for the FMM. Problem: the engine will not crank. Then follow these steps. Check to make sure all of the receptacle caps and FMM doors are properly closed. Make sure the vehicle's starting battery is good and fully charged. If the vehicle is equipped with the Agility Fuel System's drive-away protection option, this may be bypassed to determine if the no crank condition is caused by the Agility system. See your service manual. If the engine cranks with the ECU bypassed, it is an Agility issue. Please refer to Agility for service recommendations. If the engine still won't crank, this is likely a chassis issue, not a problem in the Agility Fuel System. These troubleshooting tips should resolve most issues, but if not, feel free to contact your local Agility service provider or Agility. We're here to help. At Agility Fuel Systems, we take great pride in all of our products. Our number one objective is to make sure all of our customers are satisfied. To accomplish that goal, we have assembled a team that is dedicated to you. So if you're experiencing a problem with your vehicle or are uncertain about any process or proper procedure, or you need a part, contact your local Agility Fuel Systems service provider. If you need to contact the Agility Product Support Group directly, call the number shown on the screen or email us at support@agilityfs.com. When you call, we will need your name, phone number, email, and the vehicle information, VIN, unit number, year, make, model, the name of the vehicle owner, and its current location. We will assign a service advisor who will contact you and make arrangements to have your vehicle fixed or a part shipped. Please go back and review any segments in this presentation as needed as you operate or perform service work on your vehicle. For more detail, consult additional Agility resources such as the Operation Manual, Service Manual, or Parts Manual. This video is just one part of the training that is available from Agility Fuel Systems. If you have questions, comments, or suggestions about our training program, please contact the Agility Fuel Systems Product Support Group. I'm Tony Noakes, and on behalf of the entire Agility Fuel Systems team, we thank you for watching.